Hello everyone. We have learned the basic architecture of convolutional neural networks. In this section, we will discuss commonly used architectures for convolutional neural networks. As you will see, almost all CNN architectures follow the same general design principles of successfully applying convolution layers to the input, periodically downsampling the spatial dimensions while increasing the number of feature maps. While the classic network architectures were comprised simply of stacked convolution layers and pooling layers, modern architectures explore new and innovative ways for constructing convolutional layers in a way which allows for more efficient learning. Almost all of these architectures are based on a repeatable until which is used throughout the network. Classic architectures include LearnNet5, AlexNet, VGG16, Inception, and ResNet. These architectures serve as general design guidelines which machine learning practitioners will then adapt to solve various tasks. Ian LeCun built the first convolutional neural network called LearnNet in 1988, and the LearnNet5 model was developed by him in 1998 to identify handwritten digits for zip code recognition in the Postal Service. This pioneering model largely introduced the convolutional neural network as we know it today. Convolution layers use a subset of the previous layer's channels for each filter to reduce computation and force a break of symmetry in the network. The subsampling layers use a form of average pooling. The input for LearnNet5 is a 32 times 32 grayscale image, which passes through the first convolution layer with 6 feature maps of filters having size 5 times 5 and a stride of 1. The image dimensions changes from 32 times 32 times 1 to 28 times 28 times 6. Then the LearnNet5 applies average pooling layer or subsampling layer with a filter size 2 times 2 and a stride of 2. The resulting image dimensions will be reduced to 14 times 14 times 6. Next, there is a second convolution layer with 16 feature maps having size 5 times 5 and a stride of 1. In this layer, only 10 out of 16 feature maps are connected to 6 feature maps of the previous layer. The fourth layer, S4, is again an average pooling layer with filter size 2 times 2 and a stride of 2. This layer is the same as the second layer, S2, except it has 16 feature maps, so the output will be reduced to 5 times 5 times 16. The fifth layer, C5, is a fully connected convolution layer with 120 feature maps, each of size 1 times 1. Each of the 120 units in C5 is connected to all the 400 nodes in the fourth layer, S4. The sixth layer is a fully connected layer with 84 units. Finally, there is a fully connected softmax output layer with 10 possible values corresponding to the digits from 0 to 9. AlexNet was developed by Alex et al. In 2012 to compete in the ImageNet competition. The general architecture is quite similar to LearnNet5, although this model is considerably larger. The success of this model, which took first place in the 2012 ImageNet competition, convinced a lot of computer vision community to take a serious look at deep learning for computer vision tasks. The major feature of AlexNet is that it overlaps the pooling operation to reduce the size of the network. With 5 convolution layers and 3 fully connected layers, and the ReLU function applied after every convolution layer and fully connected layer, it uses the ReLU as its activation function, which speeds the rate of training and increases the accuracy. The regularization technique it uses is the dropout. Next, we will consider inception architecture. Wondering what is the difference between architectures, let us analyze the architecture design method. VGGNet was created by the Visual Geometry Group from the University of Oxford. It was the runner-up in the ImageNet 2014 challenge. It is mostly used as a feature extraction algorithm. With many filters, it acts as a base model for single-shot detectors used for object detection. In 2014, researchers at Google introduced the Inception network, which took first place in the 2014 ImageNet competition for classification and detection challenges. As known as the Inception model, because of the Inception module present in the architecture, GoogleNet won the image. The network uses a CNN inspired by LearnNet. Its architecture includes 1x1 convolutions in the middle of the network. It uses global average pooling in place of fully connected layers. Inception has 4 different models of V1 to V4. ResNet won the ILS VRC 2015. It was the first model to beat human-level accuracies. It was the deepest network with 152 layers. The novelty of the model is that it introduces skip connections and features heavy batch normalization. ResNet reduces the vanishing gradient problem to a minimum. ResNet reduces the vanishing gradient problem to a minimum. Vanishing gradients occur when the change in weight is so low that error does not backpropagate through the huge number of layers present in deep learning models. Now that we have looked at various model architectures, it is suggested to go through the papers to get a better understanding of the same. This is the end of this section. Thanks for watching and welcome to the next period.